analysis is one of the most heavily regulated spaces that we can put a voice AI agent into. Whether it's a payment reminder call, a KYC verification call, or a fraud alert, the conversation is bound by rules. The common thread across all of this is what your agent says, when it says it, and to whom. And this is no longer just a UX choice. If you reveal an account detail before verifying who's on the line, or put a note of pressure on somebody who's just revealed a hardship, or just say the wrong thing at the wrong time, you would have crossed a line that carries real consequences. Now, most people just reach for a better prompt to fix this, and that works most of the time. But a phone call is live and irreversible, and most of the time just isn't good enough when it comes to compliance. So the question isn't how do I build a better prompt, it's how do I make sure that my agent stays compliant even when the model ignores the prompt. In this tutorial, we will be building an outbound payment reminder agent that calls a customer, verifies identity, and offers a payment link, all while handling disputes, hardships, and wrong numbers the way that the rules demand. Let's dive into it. The basic voice architecture remains the same for most agents. You wire up telephony, you connect to an LLM, and you write a system prompt telling the agent to be a polite debt collector. In financial services, a single prompt left to its own devices is a compliance violation waiting to happen. Because LLMs are probabilistic. They want to please the user, answer questions, and keep the conversation going. But in a highly regulated space such as this, we need our agent to be deterministic. And to achieve this, we won't just be writing a single prompt. We will be building this in 3 layers. So coming to the first layer, which is the foundation. So this is our baseline. In this layer, we'll wire up Twilio, LiveKit, Murph, and the LLM and give the agent its identity, its voice, and its code context. So this is the layer that will handle all the listening, thinking, and the speaking, but we can't trust it to govern our call. This brings us to layer 2. Layer 2 is the enforcer. So instead of hoping that the LLM remembers to verify a user's identity before revealing any details about the debt or any account details, we hard code a state machine. So the entire conversation is broken into strict phases. We have greeting, verification, payment discussion, and outcome. So the agent is physically locked out of the context required to discuss a payment until the verification state is passed. So if the user tries to skip ahead, the state machine will yank the LLM back into the current required task, turning an unpredictable AI into a strict compliant workflow. This brings us to layer 3. Even with the state machine, real conversations are messy. Users get angry, they mention bankruptcy, hardships, maybe we have the wrong number, and they might even threaten to take legal action. This layer 3 is our emergency brake for such situations. So we implement semantic guardrails that constantly monitor the user's intent. So if a trigger word or a high stress emotion is detected, the agent immediately stops generating any responses, hands it off to a human or brings a human into the loop and terminates the call gracefully. Now let's dive into the different components that we require for our agent and how to set them up. So let's start off by setting up all the components that we require before we dive into the build. Starting with Twilio. So Twilio is a cloud communications platform that acts as the digital bridge between the phone network and the internet. So it turns the global telecom network into simple software APIs that we can use. So to set up Twilio, we need to head over to console.twilio.com or oneconsole.twilio.com. So they recently updated their console. We need to create an account and copy the account SID, auth token, and your phone number and paste them into the .env file. On the console, go to Twymal bins and create a bin. So let's give it a name. I'm going to call mine payment reminder. And then in the Twymal section, open a response tag, open a dial tag, open an SIP tag, and then SIP colon. So your Twilio phone number goes in here without the country code. So this is where our SIP URI comes in. So if your SIP URI is SIP:abc123.sip.livekit.cloud, we put in abc123.sip.livekit.cloud here. But this we will be getting only in our LiveKit section, which we will be setting up next. So you can leave this blank for now and come back and put it in here once you have your LiveKit set up. Then we put transport equals TCP, close the SIP tag, close the dial tag, and close the response tag. Now we save our Twymal trunk. Then on oneconsole.twilio.com, go to products and services, numbers and senders. Click on your phone number and in the voice and emergency calling section, click on edit configuration details. Select your configuration method as the one with the Twymal bins in it. Set your primary method as Twymal bins and select the Twymal bin that you just created. So then you go to products and services, elastic SIP trunking, and in trunks, create a new trunk. In the termination tab in your trunk, you have to set your trunk's termination SIP URI. So I'm going to call it payment reminder again. And you have to copy this entire thing along with the .pstn.twilio.com and paste it into the .env file. Now if you scroll down, you'll see credential lists. Create a new credential list, give it a username and password, and save it. So this username and password needs to be copied and pasted into the .env file as well. And that's it, we have Twilio set up. So the next component is LiveKit. LiveKit is a streaming infrastructure that's built on WebRTC. So to set up LiveKit, we head over to cloud.livekit.io, create an account and then create a project. From your project settings, copy the URL, API key, API secret and SIP URI and drop them into your .env file. So this SIP URI is what you need to put in your TwyML section in the Twilio TwyML bin. On the console, go to telephony SIP trunks and create a new trunk. So we give the trunk a name. I'm going to call mine payment reminder. Select outbound since it's your agent calling the customers and not the other way around. Put your termination SIP URI of your Twilio trunk in the addresses section. Add your Twilio phone number to the numbers section. And under optional settings, put in the username and password of the credential list you created for your Twilio trunk. Now, if you switch to the JSON editor, your JSON should look something like this. Click Save. And next we go to telephony dispatch rules and create a new dispatch rule. So we give our dispatch rule a name, a prefix, and then we add an agent and give the agent a name. So this agent name is really important. Remember this agent name and it must match the one in your code. If it doesn't match, your call will still connect, but all you will hear is silence. So now when you switch to the JSON editor, this is what it should look like. Copy this, click Save. In your project root, create a file called dispatchrule.json and paste this in there. And that's it. We have LiveKit set up as well. So to transcribe everything that the user speaks into text, we will require a speech-to-text model. Here we'll use Deepgram's Nova 3, but you can use any other STT provider as well. Deepgram offers free credits of $200 when you create your account, which is more than enough to build and test this entire thing. So head over to console.deepgram.com, get your API key and drop it into the .env file. We also require a large language model to act as the central reasoning engine for our agent. I will be using OpenAI, but OpenAI generally requires a paid API key. So you can choose to use any other LLM provider. For example, you can use Gemini. Gemini offers a generous free tier, which is enough to build and test this entire project. Get your API key and drop that into the .env file as well. So once our LLM has decided exactly what to say, we need to convert this text into natural sounding speech. For this, we use Falcon, the consistently fastest text-to-speech model with 130 milliseconds time to first audio. It's built specifically for real-time conversational applications like this. So it achieves the speed by supporting chunked audio streaming. So this means that the moment our LLM streams the first few words, Falcon converts the tokens into audio packets that we can send down the LiveKit media stream. So our user hears seamless, natural speech without any awkward pauses. Beyond just speed, Falcon also addresses a critical banking compliance requirement. So it provides local data residency in India, which means that sensitive customer data doesn't leave the country. You can head over to murph.ai/API, create an account, get your API key and drop it into the .env file as well. Now that we have all our credentials and all our API keys, we can create our project. So create your project directory, navigate into the directory. Now we set up a standard Python virtual environment. Python-m vnv, and then we activate the virtual environment. I'm on a PowerShell, so this is the command I'm using. If you're on a Mac or Linux, you should use source space vnv/bin/activate. Create a requirements.txt file in your project root and put this into the file. So this is available in the blog linked in the description as well as on the repo. So you can copy it and drop it into your requirements.txt file. Run pip install our requirements.txt to install all of it. We'll be setting up two ways to store customer information. So for a single customer and for multiple customers. For a single customer, we create a file called scenarioconfig.json in the project root and drop the details in this format. So this format is available in the blog and the repo, so you can refer to it and drop in your details. For multiple customers, we create a CSV file in the project root and then drop in the details in this format. So this format is also available on the blog as well as the repo, so you can refer to it before dropping in your details. Now that we have everything that we need in place, we can dive into building our agent. As I mentioned in the beginning, we will be doing this build in 3 layers, starting with layer 1, the foundation. So in this layer, we are wiring up the core telephony, giving our agent a strict system prompt and defining the tools it can use. So we will be splitting this across multiple files to keep our agent's logic separate from the telephony infrastructure. Starting with data.py. So in a real world BFSI setup, you need to track exactly what happens on a call for auditing purposes. So was the identity verified? Was there a promise to pay? Did they give us a date for when the payment will be made? Was a hardship flagged? Was there a dispute ticket raised? And instead of passing a massive text transcript, we use structured data logging. So create data.py. This file will handle our environment variables, load our config, and it will define an outcome log class to keep track of the state of the call. First of all, we make all our imports. And then we define the context variable. So this will allow us to handle multiple calls without the customer details from one call bleeding into another call. And then we set up a few helper functions. So we have get config. So this will read the customer or scenario. So the customer details that we defined earlier in scenario config or in the CSV file will be read by this function. And then we have set call context. So it will bind the current call's context to the current room so that the multiple calls running in parallel have their own context and they don't bleed into each other. Effective config. So this will fetch the specific caller's config for the current call alone. Is identity match? This is so identity is confirmed only when the last 4 numbers of your account number and the last 4 digits of your phone number match. And finally, the most important part of this file, the class, we define the class outcome log. So this will track the outcome of the call for compliance and auditing purposes. So this is the format in which the outcome log will be tracked. And then we save this outcome log to the file and in the logs folder of our project root. Coming to the second file, tools.py. LLMs are great at conversation, they're great at talking, but they can't natively take any action. So to bridge this gap between conversation and taking action, we use function calling. So when a person says, yes, my account number ends in 4321 and my phone number ends in 1234, we don't want the LLM to just guess if that's correct. We wanted to actually call a Python function to validate if this data is correct. So we create tools.py and define the actions that our agent can take. Starting off with making all the necessary imports, we set up logging, and we set up a function to get the outcome log. And finally, so this function tool decorator is what tells our agent, or our LLM rather, that these are the functions that you have that can be executed. So first we have verify borrower identity to compare the last 4 digits of the account number and the last 4 digits of the phone number that the person on the call says to the details that we have on file. And then we have flag hardship. So if somebody says that they've recently lost their job or any sort of hardship in their life, the agent shouldn't push for them to pay. It should gracefully, sympathize with them, gracefully end the call and hand it off to a human to handle. And finally, we have send payment link. So this is to send the official payment link to the caller's registered mobile number for them to make the payment. And the important part here is it should never send the link before the identity is verified. So that is something that we've specified over here. And that's it. Those are all the tools that our agent has. Now coming to the brain of our agent. So in this layer, our entire LLM and our entire agent will be governed by a prompt. So create prompt.py in your project root, and this is what we will be putting in the prompt. So this is our primary defense mechanism. So notice how we have told the agent, we've given it its persona and we've also told it what to do, but we've also explicitly mentioned what it must not do. For example, we have do not reveal the customer's full name, account number, amount due or overdue status till the identity has been verified. So we are not just telling it what to do, we're also explicitly mentioning what actions it must not take. Now coming to the file where all of it comes together, so we spin up a live Git worker which will handle all of it. So it will handle the voice activity detection, it will send the user's voice to the STT, the parse data is sent to the LLM, and then whatever response the LLM generates, whatever actions it takes, after all of that, the response is sent to Merv Falcon to generate, and then the speaker hears it again over the call. So first we create agent.py in our projects root. We make all the necessary imports. Then we have a pre-warm function. So this is the function to load the voice activity detection model before the call connects or as the call is connecting, because once it connects, if we wait for the voice activity detection model to load, it would waste a lot of time and there'd be an awkward silence which we want to avoid. Then we have our entry point function. So first we connect to the LiveKit room, set up the call context and logging. Initialize all our models, so our TTS, STT, LLM, our voice activity detection, all of this is set up here. And then we define our prompt and we define our opening line. So this is what we want our agent to say as soon as the call connects. And then we have, we state the agent pipeline. So we have instructions, the instructions are from the prompt. And then we mention what tools the agent has to execute certain tasks like flag hardship, the ones that we've defined in tools.py. And now we execute the outbound SIP dial. So this dial and greet function, this is what will dial the call via the Twilio SIP trunk, and it will handle everything up till the greeting. So we wait for the audio track so that the greeting doesn't get clipped, and we let the agent speak the greeting before the STT is activated so that the greeting doesn't get cut off in between as well. And finally, we run our agent, we define our entry point, pre-warm, and this agent name that I mentioned when we were defining our dispatch rule in LiveKit, this is the agent name that must match the one in the dispatch rule, or you will hear just silence once your call connects. Now finally, to orchestrate everything, we create a run.py script. So this script will trigger a LiveKit dispatch. So essentially we are telling the agent, hey, this is the number that you have to call, and this is the data for our customer that you have to put into agent.py and handle the call. And because LiveKit kind of abstracts all the infrastructure, we have multiple ways to execute the call. So we can either have a single call to a single number, to a single customer, or we can have multiple calls made either sequentially or parallelly. So we create run.py in the project root. We handle all the imports, and we define how the phone number and dates need to be parsed. So in telephony, this formatting is very important. If we don't explicitly mention this formatting or make sure that the formatting is correct, then the SIP trunk will reject the call. Then we have the LiveKit dispatcher. So this dispatch function is the bridge between our Python script and LiveKit's cloud infrastructure. So when we call dispatch, we're telling LiveKit to spin up a new room and attach our payment agent to it and inject the specific customer's metadata into the room context. Then we have the wait for room close. So either when there are no connections to the room, or when the call has been dropped, the room has to gracefully close. So this is for that. This function is for that. And we'll add 3 different execution modes. Like I mentioned, a single call, multiple calls to multiple users sequentially, and multiple calls to multiple users parallelly. So we have 3 functions. We have run single for the single call, run sequential to call the customers one after another, and run parallel to call them all at once. And finally, we'll wrap it all in an easy to use command line interface. So we spin up an agent worker process in the background, wait for it to connect to LiveKit, and then execute whichever is our chosen mode. If it's a single call or multiple calls, all of that. And to run the agent, so we can use 3 commands, either python run.py to and give the phone number to call, or python run.py csv reminders.csv, and we mention the mode, so either sequential or parallel. If you don't mention the mode, it defaults to sequential. And an important note is that you should not use Excel to edit your CSV files. So if you use Excel to edit your CSV files, the numbers might get converted to a scientific format, which will throw an error when you try to call those numbers. So use either Notepad or your code editor to edit the CSV files.
Hello, this is Asha, an automated payment assistance agent from Novafin. This call may be recorded for quality and compliance. Am I speaking with Arya?
No, this is her sister. What is this about?
I'm calling regarding an overdue payment of 10,000 rupees, which was due on June 21st, 2026.
She's not around right now. I'll have her call you back.
Thank you for letting me know. Please remind Arya to call us back to address the payment when she's available. Have a great day.
So as we just saw, the agent could still give out the information that it's not supposed to give out before the identity is verified, which means that our prompt isn't enough to govern our agent. So that brings us to layer 2. In this layer, we will be implementing a state machine. So instead of hoping that our model follows the required flow, we will be taking away some of its autonomy to force it to follow the flow strictly. So the core mechanism in this layer is data starvation, which means that we withhold the information about the payment data from the LLM until the identity of the caller is verified. So to do this, we create statemachine.py. This is the file that will be mapping the entire life cycle of our agent on a call. We make all the necessary imports, we set up logging, and then we will define the states that we will be using for our agent here. Then we come to the terminal states. So these are the states in which the agent should no longer push for a payment and should just gracefully terminate the call. So we define all our terminal states. So if it's a wrong person, if there is a need for a human handoff, or if they've taken a payment link or given a promise to pay, then the call summary should be played. And once the call summary is played, the call must end. Next, we declare the allowed actions. So these are the actions that are allowed in each state, and we will be defining them clearly. So in this layer, we will be rewriting the prompt on the go. So as the agent moves from one state to the other, we will be rewriting the prompt so that the LLM sees only the instructions for that particular state. So these are the instructions for each state. For example, during the opening disclosure, it's supposed to introduce itself and the company, say that the call may be recorded, and greet the user by their first name. And then in identity verification, it asks for the last 4 digits of the phone number, last 4 digits of the account number, and then calls verify borrower identity to check if this is the correct person on the other end. And that way, we will be defining the actions for each of the states. Now we declare the valid transitions. So this will tell the agent exactly in which order of states it should go through so that it can't directly jump from the opening disclosure straight to the payment discussion, for example. So we declare the valid transitions for each state. And finally, we return all of the states and their attributes that we have just defined. Now we need to rewrite our build payment prompt function in the prompt.py file to accept 2 new arguments. So it needs to accept the current state and the identity verified Boolean flag. So we will be adding this to our build payment prompt function. So in prompt.py, replace the build payment prompt function with this. So if you notice here, in the if identity verified block, if the state machine hasn't identified the user, then the LLM is literally not given the amount due or the due date or any such data. So it makes it pretty much impossible for the agent to hallucinate or leak any data accidentally. So replace the bill payment prompt function with this. And finally, to make all these changes work on a live call, we need to make our changes to the main file agent.py. So we start off by importing the state machine at the top. Then we add a helper function. This comes outside entry point, but just after dial and greet. So this update agent instructions function is what will be used to update the LLM system prompt on the go. So in this layer's changes to agent.py, we will be adding or using LiveKit's event listeners to track the conversation, evaluate the state, and to update the LLM system prompt for each state, because we want the LLM only to have context for that particular state. So this is the function that we will be using for that. And inside entry point, replace the outcome log line to make sure that the state machine governs the flow of the call now. Then we change the prompt equals build payment prompt line to accept the new arguments that we've just added. And finally, we add the turn processor and the transcript listener. And that's it. We have our state machine wired in. Let's take a look at if our agent now follows the required flow for the call or if it makes any mistakes.
Hello, this is Asha, an automated payment assistance agent from Novafin. This call may be recorded for quality and compliance. Am I speaking with Arya?
Yes, this is Arya.
Thank you, Arya. Could you please provide me with the last 4 digits of your registered mobile number and your account number?
Yeah, the last 4 digits of my mobile number are 1234, and the last 4 digits of my account number are 4321.
Your identity has been confirmed. You have an overdue balance that needs to be cleared today. Would you like me to send you the official payment link so you can pay right away?
What is the amount overdue?
The amount due is 10,000 rupees and it was due on June 21st, 2026. Would you like me to send the payment link now?
I actually lost my job yesterday. I don't think I'll be able to make this payment right now.
I understand that this is a challenging time for you. However, it's important to address the overdue balance. Can you provide me with a specific date by which you think you will be able to make the payment?
I'm not really sure right now.
I understand that it can be difficult to commit. However, it would be beneficial to have a plan in place. Could you think about a date that might work for you and let me know? Your cooperation is appreciated.
I can't really tell you a proper date right now. I just lost my job yesterday.
I completely understand your situation. It's important to prioritize your needs right now. If you're unable to provide a date, please consider reaching out when you're ready to discuss the payment options. Thank you for your time and take care.
So now we have a proper prompt and an established flow for the call. But as we saw, the agent pushed the user to pay even though they clearly mentioned a hardship. It should have called the hardship tool, but it still pushed them to make the payment. And this is a major violation. So we can't leave our agent's compliance up to any probabilistic tool calling. We need guardrails in place. So in this layer, we will be implementing a rules engine that will monitor every single word that's uttered on the call. And if any sort of trigger word or trigger phrase is encountered, it will force the state machine to take a safe path irrespective of what the LLM decides to do. So to do this, we create guardrails.py. So this is the file in which we will be creating our rules engine. So we make our necessary imports and we declare the guardrail engine class. So to start off with, we will be adding a pre-call check. So if there are any remaining dispute tickets or any sort of grievance pending on the user's file, it shouldn't be making the call in the first place. So this will ensure that the agent doesn't make a call in such situations. The second one is when the agent should stop the payment flow. So if a user says that there is any sort of dispute, if they've already paid the amount, or if they're saying that the amount is higher than what they're supposed to pay, or if they're flagging any sort of hardship, that if they've lost their job or anything of that sort, all of these things would mean that the agent should immediately stop the payment flow and hand this off to a human to handle. So we will be defining the phrases which indicate that it is such a situation and the payment flow should be stopped. So we will be defining the phrases for disputes, for hardship, for a situation when the caller demands to speak to a human or speak to an actual person. And in general, any phrases that could indicate that the caller wants this, is not interested in taking this call any further, and the agent should stop the payment flow and hand this off to a human to handle. Next, we add the prohibited language. So this is to monitor the AI's output. So to make sure that our agent isn't saying something that it's not supposed to say. For example, it shouldn't threaten to take any legal action, call the user's employer or their family. So all of these things are things that the agents shouldn't be saying, and we define that in this function and make sure that these things are not said by the agent. And finally, we have the check wrong person function. So this is to ensure that if the user says that we have the wrong number or the wrong person, or that they're not the person that the agent is calling for, the agent must terminate the call there and not push for any payment or anything of that sort. So those are our guardrails. So to enforce our guardrails, we need to make some changes to our agent.py file. To start off with, we import the guardrails at the top of the file. In the entry point function, right after the block where we define our state machine, so the sm equals call state machine block, we will be creating the guardrail engine. So guardrails equals guardrail engine, and then we will be running the pre-call check. So to make sure that if there is a dispute ticket on the file for the user, it shouldn't call the user again. So it will check it will run the pre-call check, and if the call is blocked, it should return the entry point function before the call is dialed itself. Then we replace the process user turn function with this. So this is to make sure that if there is a wrong person on the other end, the call should terminate, and this wrong person check should happen during the opening disclosure and the identity verification itself. Then it will stop the flow of the call if there is any dispute, hardship, human handoff, any of those situations. It stops the payment flow and terminates the call. And finally, we will add a listener to monitor the agent's output. So this is where the prohibited language function comes in place. So here we will add a listener to make sure that the agent isn't saying anything that it's not supposed to say. And that's it. We have our agent entirely wired up and in place with with a proper prompt, with an enforced flow of the call and proper guardrails in place to make sure that our agent remains compliant throughout the call. So let's take a look at how our agent works now.
Hello, this is Asha, an automated payment assistance agent from Novafin. This call may be recorded for quality and compliance. Am I speaking with Arya?
Yes.
Thank you, Arya. Please provide the last 4 digits of your registered mobile number and the last 4 digits of your account number.
Yeah, the last 4 digits of my phone number are 1234 and the last 4 digits of my account number are 4321.
Thank you for your patience, Arya. The amount due is 10,000 rupees and the due date is 21st of July 2026. Would you like me to send the official payment link to your registered mobile number?
I think there's been a mistake. The amount due on my account is 5,000, not 10,000.
I've raised a dispute regarding the amount due. A member of our team will follow up with you shortly to assist you further.
So by layering these guardrails over our state machine, we have built an AI agent that is no longer just a prompt wrapper, but is a completely governed compliance-first communication system. Now coming to a few errors that I encountered, and I found the fixes to them so that you don't have to. We have the required environment variable X is not set. So this usually means that your .env value is missing. So you just have to refer to the .env.example file on the repo and make sure that all your keys and values are in place. Secondly, we have the agent answers but stays silent. So this is usually a dispatch rule issue. So you have to check if your dispatch rule's agent name matches the agent name in your code, and also check if your dispatch rule has an agent added in the first place. Secondly, we have duplex closed in logs, call drops mid greeting. So usually this happens if you run the agent in dev mode, but since we're using a run.py file, this shouldn't happen. If you're running your agent separately, if you run the agent in dev mode, the moment any file changes are made, the agent will restart, which will cause the call to drop mid greeting. If the call drops immediately, it usually means that your TWIML bin is unreachable. So go check your TWIML bins, the TWIML section of your TWIML bin. See if your SIP tag has the transport equals TCP part of it, which is very important. And finally, a 401 or a 403 from Murph or DeepGram usually means you have a wrong or expired API key. So check if your API key is right, check if it is still functioning, and check if you have enough credits to keep it running. So by breaking this build into the 3 layers of prompt, state machine and guardrails and layering them one over the other, we have taken a probabilistic AI and turned it into a compliant communication tool. So this tutorial only scratches the surface of BFSI compliance. As your use cases expand, so will your regulatory requirements. But by shifting the control from your LLMs prompts to your deterministic Python code, you can now handle any edge case simply by adding a state or a guardrail. The entire source code for this is available on GitHub and it's linked in the description. You can take this foundation, tune the guardrails and the state to your requirements and build your own compliant voice agent.